Hi, how are you? I hope everyone is doing well. In this video, I'm going to answer Mathematics Paper 2 2024 GCE. We're going to look at section B. This part is just section B, and you should know that section B consists of 6 questions, and that of 6 you are asked to write only 4. So we're going to answer 5 of those 4 questions. Okay, but remember you're supposed to answer 4. Okay, so we're going to answer linear programming, trigonometry, cubic function, statistics, geometry, together with this question is under linear programming. That is the topic, linear programming. Now, without wasting much of the time, we can jump right into the question and solve it. Now, there are few things that you need to know that I need to explain to you before we proceed answering this question. Okay, because some of you will not understand the symbols I'll be using. So let me write down here linear programming language. Linear programming language. Let's understand it together. Number one, you can at least this is the term that you always find most of the time in the exam. Even this exam which is coming in, is it October, November, somewhere there? You may find this term, okay? This vocabulary. So at least means greater than or equal to. All right, greater than or equal to. Now, this is the symbol for greater than or equal to. Then you have at most. Okay, at most is less than or equal to. All right. Then number 3, should not exceed. Should not exceed. Exceed is the same as should not be more than. Now, should not be more than, it means it should be less than or equal to that number. Okay, it should be less than or equal to the certain quantity. All right. What else? Now, this is another term that is usually misunderstood. When they say the number of x should be at least twice the number of y. The number of x should be at least twice. Now, at least we know this is symbol. Let's say the number of x is here, should be at least this is the symbol, twice the number of y, like this. So the way you'll be reading the statement is the way you are writing. It is step by step. When they say the number of y, when I say y, that is the representation of a certain quantity. Let's say maybe like this one. This is what? Chairs. Okay. Type A, type B. Maybe type B will be represented by y. Then type A by what? By x. Okay. So that's how it will be. So let's say the same. The number of type B. Okay. Type B is y. Must be 3 times z. Okay, or must not be, okay, or must be at least, whichever symbol they have used here. Okay, the number of type B, let's say, to be at least 3 times the number of type A. This is how you write the inequality. All right, or when they just say the number of type B. Okay, I've said type B to represent y, type A to represent what? X. When they say the number of type B to be at least or to be more than the number of type A, or should not exceed the number of type A. The number of type B, which is y, should not exceed the number of type B, type A, which is what? Which is x. So it will be like this. Let's now go to this examination question. Okay, having understood this, I think this will be easy. So they're saying, answer the whole of this question on a sheet of what? Graph paper. On a sheet of graph paper. Mapulanga's carpentry shop makes two types of chairs, type A and type B, for sale. The cost of making one chair of each type, not type A or not type B, but of each type. Type A to be 2000 is 2000. The cost of making type B is also 2000. Then this person, they're saying the shop has 1400 available for making chairs. Understand this. This is the money this person has available. So whatever number of chairs you're going to make, either type A or type B, the cost shouldn't exceed 140,000. Okay? It is available for what? For making chairs. So this is the money available for making chairs. Whatever you're going to do, it shouldn't exceed what? This. So just from this, we can come up with one inequality. All right? We can come up with one inequality. But let's proceed. The number of chairs of type A must be at least. So at least here. While that of type B must be at least. Another at least here. So these are just the easy, simple marks. Then the first question, which is question A, if X is the number of chairs of type A and Y the number of chairs of type B, write three inequalities which represent these conditions. Wow, this is nice. So we can write, this is question 7, question 7A. You can just write question 7A here. Let's write the inequalities. So the first inequality, they're saying, then the cost of making one chair of each type is 2000. So we can write 2000. I'm using 2000 here. I'm using a pen because I want it to be visible. 2000x plus 2000y. Now, we are not told here at least or at most. Now, when you are given the maximum amount, this is for this project, then you should use less than that amount or equal to that amount. Don't exceed the capital. This is the money that is available for making chairs. So this 0.00, 0.00, you add them later, they will just confuse you. So you have 2000x plus 2000y. 2000 of type A times, this is amount, okay, times the number of chairs. 2000 quarter times the number of chairs of type B should not exceed 140,000. Now don't leave this inequality like this. Reduce, okay? So you can simplify. So you have 3 zeros, 3 0, 3 zeros. So you can cancel these 3 zeros so that we know this is our starting point. These 3 zeros, 3 zeros, even here 3 zeros. So you have 2 here, 2, then you have 140 here. So you notice that a 2 can also go in all the 3. Okay, so since we are using calculators, so you can just divide. Since 2000 can go into 2000, then just divide 140,000 divided by 2000 if it is divisible. And I'm sure it is divisible. 2 here, we cancel, 2 here, we cancel. Just 2 into 14 here is 7. With this 0 becomes 70. Therefore, the first inequality is x plus y should not exceed 70 here. Like this. This is the first inequality. Okay? That's the first what? Inequality. Now, When we proceed here, if we proceed, we have this. The number of chairs of type A is X, by the way, to be at least, or must be at least 20. Okay, so this is direct. You can just say type A, which is X, to be at least greater than or equal to 20, like this. Okay, wow. Then when we proceed to say, wow, that of type B must be at least 10. So type B, which is Y, at least greater than or equal to 10 here. 10, we are done. So this is 1 mark, and then this is 2 marks because it involves calculations. That's why here it is what? It is 4 marks. All right. So we are done with question A. Let's go now to plotting, okay, or graphing these inequalities. So let's read question B. Question B is saying, using a scale of 2 centimeters to represent 10 chairs on each axis. Okay, so on both axes, 2 centimeters to represent 10 chairs. Draw X and Y axis for the range in the X-axis should be from 0 to 70. This is what it means. Then Y-axis 0 to 70 as well. Okay, shade the unwanted region to show clearly the region where the solution of the inequalities lie. 4 marks. This is very simple. Now, you should understand that the inequalities for paper 2 doesn't have what? Inequalities don't have the negative party. So, I advise always to start here, from here, the second box. This is the second box. Yeah, at the end of the second line, I mean, starting from the bottom, this is the second line, and the second line from here. So start from here, you draw this side, a line, okay, using a ruler, then even this side. So what we're going to say here, I'm using a pen because it is visible. If I were to use you're supposed to use a pencil, by the way. If I'm to use a pencil, it may not be visible to you. So this is 0, and then this is 2 centimeters. They told us to use 10 centimeters. So this will be, 10 units. So to be, this is 10, this is 20, all right? This will be 30, all right? This will be our 40. This will be our 50, This will be our 60. This is our 70. Okay, so I got to from 0 to 70 in the x-axis. All right, so this is our x-axis. Okay, I'll draw the line. That is our x-axis. All right, then in the x-axis, it is, you write here is number of chairs of type B, type A. Okay, number of chairs of type A in the x-axis. Then in the y-axis here, it is the same. 2 to represent 10, so it will be 10 here, 20, 30, 40, 50, 60, 70. Okay, this is the y-axis. All right. Now, let's write even here number of, so you can just say number, right, like this. Number of chairs of type B. Okay, number of chairs of type B. Okay, so this is what the graph look like. Okay, now let's plot these inequalities. This is very simple because these inequalities are very simple. I'm going to show you how you just graph them directly. See, you can first start with single inequalities. All right, you can start with this one. Okay, let's start with any, because all of them are simple. Check. If, it's a condition by the way, if the coefficient of x and y is 1, okay, if the coefficient is just the same as, is just 1, here is 1, here is 1, then there is a number here like 70. It means that our line or inequality is passing through this 70 and 70 on the other side here, on the x-axis 70. Okay, now again, if again it's the same as if there's 180 here, then on our graph of 180, it means that it's passing through 180 in the x-axis and 180 y-axis. So it goes like this. If this, that is 180. Okay, now we can graph this. So is this, our graph is passing through 70 in the y-axis and 70 in the x-axis. Okay, like this. Okay, like this. Let me just show you like this. So it's passing through 70 here and 70 down. Okay. Okay, 70 like this. Okay, yeah. You see, it's passing through 70 out, down, and 70 up here. So why is it a solid line? Because it's a solid line because here there is and greater is less than or equal to. Now where do we shade? Since the wanted region is on the less than part, we're going to shade on the greater what? Greater than. All right, like this. So we shade this side. Okay, this side, this is why we shade. Then indicate this is the inequality x and y. So this is the equation. By the way, on the graph paper you use equation. So this is 70. All right, then another one is x is greater than or equal to 20. So this is where x is 20. So you can just draw a straight line here at x is equals to 20. All right, so it's going to be like this. Okay, go to 20. Then this is greater than or equal to, we're going to shade the less than part, which is this side, less than. Okay, so we can indicate here this is x is equals to what? 20. X is equals to 20. Then the other one is y is greater than or equal to 10. So where y is equals to 10 is here. Is here where y is equals to 10. So you can do as wise, draw the line here at y is equals to 10 like this. It's a solid line as well because it is z or equal to. If it is just less than or greater than, sorry, all right, but it's fine. So this is, you shade the less than party because the wanted region should be on the greater than what? Greater than party. So this is y is equals to 10. Okay, y is equals to 10. So now this is the wanted what? The wanted region. This is the feasible what? Region. That is the wanted region. So we are done graphing this. We can go to the next what? Next question. Now when you read this next question here. Is saying, given that the profit on a type of chair of type A is 60 kwacha and that of type B is 30 kwacha. These are profits. Profit, I mean, this is 30 kwacha. How many of each chairs, how many chairs in short, how many chairs of each type should be made to maximize profit? Then calculate the maximum profit. This is very simple. This is C and D. So we are using the same graph. So we are going to come up with what we call objective function. Okay, an objective function. So let me write like this. So here we're going to have an objective function. Okay, so what question is this? Let's check. This is question C. Okay, question C. So question A is this one. Question B is, this is question B. Then this is question what? Question C. Make sure to indicate the question numbers. All right. Now, this is the objective function. Now, the profit on the sale of on a type A chair is 60. So we're going to say, since type A is being represented by X, we're going to say 60 X plus that of type B is 30. So it will be 30 Y is equals to Z. Z here is the maximum profit. Okay. I mean the profit that you make. So it can be a maximum profit, minimum, or yes, it's just the profit that you make. Okay. Total profit. Now we are going to use the coordinates. We're going to use the coordinates that covering the wanted region. So if you look at the wanted region here is being surrounded by how many coordinates? So since it's being surrounded by 3 inequalities, so automatically you have 3 coordinates. You have 1, 2, and 3 here. So what are the coordinates here? The coordinates here is 20. The value of X here is 20, 20, 10. Y is 10. Okay. Then the value of X here is 20. The value of Y is 50. So we're going to write 20, 50. Okay. Then finally here the value of X is 60. So 60, 10. So these are the coordinates that we're going to use here. Okay, let's start with this coordinate. So the value of, so it will be 60 times, what is the value of X? The value of X here is 20. Okay, so it will be 60 times 20 plus 30, and the value of Y here is 10. Okay, so when you calculate here, you are going to find 1,500. Okay, 1,500. So it is 1,500. This is kwacha currency, 1,500 kwacha. Then you also test this one. All right, it will be 60 times, what is the value of X? 20 plus 30 here multiplied by the value of Y, 50, is equals to, so this is 1,200. This is 1,500. So 1,200. So it is 2,700. 2,700 there. Okay. Then let's test the last one. Last coordinate here is 60 times, what's the value of X here? The value of X here is 60. So it is 60 times 60 plus 30 times 10. Okay, so 60 times 60 here. So when you punch these on the calculator, you're going to have 3,900. Okay, 3,900. Now, when you look at these three, when you compare these three, which one is giving us the highest amount? Automatically, it is this calculation. So, you can say, therefore, Mapulanga should make, okay, Mapulanga should make, how many you've used 60? So 60 chairs of type A, and we've used 10 here, 10 chairs of type B to maximize profit. Okay, to maximize profit, because this is the one that is giving us the maximum what? Maximum profit. Now, question D is saying calculate the maximum what? The maximum profit. You notice that we've already calculated the maximum profit here. So question D, let me just write it here. We've already calculated the maximum profit. How? So just to copy this, how? Because we've already tested everything here. So the one that is giving us the highest amount here is the maximum what? Maximum profit. So it's going to be 60, just to copy the way it is, 60 times 60 plus 300, 300 times 30 times 10. Okay, so when you do your calculations here, it's going to be 3,600 plus 300, which is giving us 3,000 when you add 900 as the maximum profit, as the maximum profit. So that's all to this question. Look at this. The first solutions were here, so everything should be done on the graph paper. So this is the first one. The inequalities, the graph is here, and the calculations are on the other side. Okay, thank you so much for watching. If you are still together up to this point, consider subscribing, liking the video as we prepare for the next video. Greetings, ladies and gentlemen. Welcome to Nostech Academy. I hope everyone is doing fine. As for me, well, I'm very fine. In this video, I'm going to solve this trigonometric question which came in 2024 GCE Paper 2. Alright, so firstly, before we jump into solving the question, I would like to thank all the subscribers who have subscribed to the channel. Please, if this is the first time being on this channel, consider subscribing, liking the video, and also leave a comment in the comment section. Thank you so much. Let's go into the question. Let's solve the question. Now, the question reads, this is question 9a. The diagram shows a triangle PQR in which PR is 8.9 centimeters, QR 12.5 centimeters, and angle R, which is this angle, PRQ, is 130.6 degrees. Alright, then you know these signs, the sides. Now, the first thing to note here before you start solving is to identify the topic. The topic here, this is trigonometry. Now, under trigonometry, there are two rules. There is the cosine rule and the sine rule. Now, the cosine rule, we use the cosine rule when, number one, when you are given all the three sides. All right, when you are given all the three sides, we use the cosine rule. Secondly, we use the cosine rule when you are given two sides and an angle, an included angle, meaning the angle should be in between two sides. Okay, if this angle was here, we can't use cosine rule because there is the side angle and you don't have a side here. We have another length here. The side we are given is on the other side. Equally, if this angle was here, we can't use the cosine rule. We only use the cosine rule if the angle is in between the two sides, or we are given all the three sides. That's when we use the cosine rule. Then you may ask, then how do we use, or when do we use the sine rule? We use the sine rule when we cannot use the cosine rule. It is as simple as that. When we are not given all the three sides, and when we are not given the side angle side, we use the sine rule. Don't be on pressure knowing, oh, the side angle side. No. If it is not a cosine rule, definitely it is a sine what? A sine rule. All right. Now, let's solve the question. The first question is calculate the distance PQ. This is length PQ. So you're asked to find this distance. Now, how can you find this distance? It is very simple, very simple. Number one, write the side, opposite sides. This angle here, its opposite side is here, is this side. So you write with a small letter. So it will be small letter R. This angle here, angle Q, its opposite side is here. So we're going to write Q, this side. Why are we doing this? We want to come up with a formula. This angle P, capital letter P here, its corresponding side is this small letter P. Now, from what we've written here, we can come up with the formula. All right? So we can say always start with the side that is the one that is missing, that is in question. So we're going to say R squared. Is it clear here? R squared is equals to P squared plus Q squared minus 2, these two sides you multiply them, just P Q cos R here, okay, which is capital letter what? R, okay, cos R. Then it's just a matter of substituting. We are going to substitute R with PQ, so we're going to write PQ in bracket squared. Okay, if you just leave it, it will mean that only P is squared. So just write in brackets. Then P, look at P. P is 12.5. So it will be 12.5 squared plus what? Plus 8.9 squared minus 2. Open bracket, P is 12.5 this time around without a square. Open bracket, Q is what? Q is 8.9 cos R, the angle there, which is 130.6. Now, do you know that you can punch everything here on the calculator? But please don't do so. Just worker, because you need to show you're working. What you are doing, you need to show. So what we're going to do here, we're going to say PQ squared is equals to, what is 12.5 squared? So 12.5 squared, this is giving me 156.25 plus, what is 8.9 squared? 8.9 squared is 79.21. Then you can multiply this with 2 times this times this. So it's going to be negative, of course, because these other two are negative. So I'm going to say 2 times 12.5 times 8.9. Okay, it's giving me 222.5. all right, cos 100 and what, and 30.6. okay, 0.6. Then here, be observant. You can only add these two, because we can subtract this one because there's a cos. It's the same as you have 2 plus x. okay, 2 plus x, we can't add 2 plus 2x, you can't add because they're unlike terms. So let's just add these two, 156.25 plus plus what, 79.21. all right, it's giving me 2. So PQ here squared is equals to 235.46 minus 222.5 cos 130.6. okay, now we can punch everything on the calculator here at this stage. So you can say 239 minus 235, sorry, 0.46 minus 222.5 cos 130 at the same time. So you can say, all right, so after punching everything here on the calculator, it's giving us PQ is equals to 380.25726.334. okay, 3341652. Then what you do here, guys, we square root. We want to find the value of PQ, not the value of PQ squared. So what we're going to do, we're going to square root both sides. okay, so this square side 2 and this will cancel, so it will be, therefore PQ is equals to, what is the square root? What is the square root of this 380 this number here? So it's giving me 19.5001862. So you should be confirming as well as I'm solving. Sometimes we're humans, we can make just silly mistakes. Okay, just a simple mistake here. So when you notice a mistake, please comment in the comment section there. There's no problem, but I always do my best to make sure that I minimize making mistakes. Sure. So after doing this, we round it off. Now we round it off to what? That is the issue. So what you do when you reach this stage, there is an instruction on the page of the mathematics paper 2 which says that if the degree of accuracy is not specified, leave your answer correct to 3 significant figures. Okay, something like that, 3 significant figures. So here, the degree of accuracy is not specified. So we can leave it to 3 significant figures, 1, 2, 3. Alright, so this is the third one. Then, so to be PQ is equals to 19.5, what are the units? Centimeters. 19.5 centimeters. Alright, so this is question, let's write the question number, question 9A, Roman numeral 1, if I'm not mistaken. Yes. So, 5 what? 5 marks. Okay. 5 marks. Let's go to question 2. Alright, question 2. Question 2 is saying find the area of the triangle. So the area of this triangle. There's no problem. This is very simple. Okay. So this is question 2. This is the formula for this area of the triangle. I'm going to say area is equals to half. Okay, half. Then the two sides. Okay, the two sides, the already given sides. We're going to use this one and this one. So we're going to say PQ. Alright. PQ. Then not cos, but sine. Even if it is sine rule or cosine rule, we use sine on the formula. Sine, the angle given, sine r. Okay, the angle is r. Now, someone may ask, now what if we use this side r? If we use side r here, we can't use the angle here, side its corresponding angle. Okay? Now, if we use this side, this is what I mean. If you use this side as 19.5 and this side, then we're supposed to use the angle which is here, and we don't know this angle, and it's not easy to find. So make sure you use the two given sides and the angle which is already there. Okay? In other words, the letters shouldn't repeat here. If you write P here, you shouldn't use the angle P. If you write Q here side, you shouldn't use PQ here. That's why every letter here has been represented P, Q, and R. Now let's substitute. Area is equals to half. The value of P, as you can see, is 12.5. Okay? 12.5. The value of Q is 8.9. Alright? Sine, the angle is 130.6 degrees. Okay? So area is equals to, so say half of 0.5 times 12.5 times 8.9. This is giving me 55.625 sine 130 or 0.6 degrees. Okay, 0.6 degrees. So if you punch everything here on our calculator, we're going to find 130, so 130.6. 42 is giving me 42.234,466,470,503. When you round this one off to 3 significant figures, we are going to have 42 point. This is the third number here, and after this there's a number which is less than 5, so we can't add 1 to this one, so these two just remain the way it is. Since it's area, it will be centimeters what squared. Okay, centimeters squared. Next question. Shortest distance from R here to P PQ. R to PQ. This is very simple. So, shortest distance is easy to find as long as the base, the side, the first question was correct and the area is also what? Is also correct. So, this is the third question. Shortest distance, let me just write SD for shortest distance is equals to 2 times area, A which is area, times, divided by base. Okay, so the base here is PQ. In other words, it is 2 multiplied by area over PQ, which is the base. So 2 times the area is 42.2, 42.2, then PQ is the base. The distance we've calculated here, 19.5. So we're going to substitute here with 19, not 18, 19.5. Then let's calculate, let's punch everything here on our calculator. So it's giving me 4.328205. So when you round off this one to 3 significant figures, it's going to be 4 point. This is the second significant figure, this is the third. Now look at the third significant figure. So we're going to write 3. After this 2, there is a number which is greater than 5, so we can add 1 to this 2 and becomes what? 3. The units, it is centimeters. Now when you compare this one with the rest of the sides, this is 4.3. Now look at the sides given here. This is 8.9. This is 12.5. This side here is 19.5. We calculated as 19.5. The question is 4.33 the shortest distance? Yes, which means that we are doing the right the right thing. Okay, this is the end of part 1, 9a. Let's solve now the equation. Let's solve the equation. Okay, so we're asked to solve the equation. This is under trigonometric equation. This is B, and the equation you're given as 2 sine x, okay, is equals to 1. Then we are given that, so this is the equation anyway. Then this is the range, this is the guidance where our answers should be. Now when you're given this equation, the first thing, since there is a number in front of this trigonometric signs, this sign, so you have to divide both sides by this number which is in front, and this is 2. So this 2 and 2 cancel. Therefore sine x is equals to half, which is 1 over what? 1 over 2, or 0.5, just 0.5. Okay, then we need to find sine inverse, okay, so that the inverse and this one cancel. So in other words, we can just say x is equals to sine inverse of 0.5. We are finding a reference angle in the first quadrant. Okay, there's a full video we've done on the trigonometric equations, so this is simple to those who've watched the video before. So sine 0.5, sine inverse of 0.5, okay, 0.5 is simply 30 degrees. 30 degrees. Now look at the range. They're saying our answer should be between 90 degrees and 240. Now check this out. This is the quadrant. This is the first quadrant. All trigonometric equations are equal. So we have cast, you use the cast diagram, CAST. In the first quadrant here, which is 90 degrees, all trigonometric equations, sine, cosine, and tangent are positive. In the second quadrant, which is 180 here, only sign is positive. In the third quadrant, which is up to 270, this 270, yes, only tan is what? Positive. In the fourth quadrant, which is 360, only cos is what? Positive. Here all are positive. Now, the question is saying, now how can we know that this one is positive? Check the coefficient here in front of 1 over 2. Is 1 over 2 negative or positive? It is positive. Now where is sign positive? Sign is positive in the first and the second. Okay, first and the second quadrant. Now the other question that you may ask yourself is, are we supposed to include these 90 degrees from 0 to 90? No, it's not from 0 to 180 or 0 to 270. They're saying it's 90, between 90 and 270. Now where is sign positive between 90 and 270? It's of course here, and this is 180. So what do? Our answer should be less than 180 but more than 90. Okay, less than 180 but more than what? 90. So we're going to write, since it is in the second quadrant and second quadrant is 180, so we're going to subtract one. We're going to subtract this reference angle here. This is called the reference angle, and is always found in the first quadrant. The reference angle, we subtract the reference angle from 180, which is just going to be 150. Yes, as the answer. Okay, it's very simple to calculate. It's just that I was explaining, that's why I've taken a little bit of time. It's just a mark, it's just 1 mark. Okay, now on the same question, there is another question here, same question, question C. This is an algebraic question. And they're saying simplify. An algebraic question that came along with trigonometry. Okay, so we are asked to simplify, and we only have one term here divided by or separated by this division sign. So what you do here is you factorize. On top here, 3 is common, so you can write 3. There's x to the power 3, x to the power 2. So x to the power 2 is common. It can go into this and this. Open bracket, 3 into 3 cancel. X to the power 2 into x to the power 3 will just remain with 1x, if I'm not mistaken. Yes. 3 into 6 is just 2. Okay, 3 into 6 is 2. Then x to the power 2 into x to the power 2, x to the power 2 will cancel. So it's just like this. Then down here we can also factorize. X is common, that's all. X into x squared is just x, minus x into x remaining with just what? Just 2. Then here we can first cancel out these 2. Okay, the next step you can just write 3x to the power 2 of x. But if you notice here, x can go into x to the power 2. So you can simply say x into x to the power 2 is just 3x. Okay, 3x, as simple as that. That is the answer. Then the whole question 12 is fully answered. Okay, but if you wanted here, don't be on pressure. You can cancel from here, but you can just make a mistake. Alright, you can make a mistake here. It is x to the power 2, then x to the power 1 here. So you can also cancel one of the x's here, and this x will remain with just the 3x. But the way I've done it here is proper. It's just okay. So that's the end of this video. Please remember to subscribe and like the video. Let's go to the we'll go to the next question. Good morning, guys. Good afternoon, good evening, whenever and wherever you're watching this video from. Welcome to Gnostic Academy. In this video, I'm going to show you how to solve this cubic function here, or polynomial. All right. So we're going to answer question 10A and 10B. So if you notice clearly here, the whole of 12 marks is not coming from cubic function only, but also there's a calculus question down here, which is 3 marks. We are asked to find the equation of the normal to the curve at this point is 3 marks. So cubic function only here, or polynomial, is it 9 marks? Yes, so it is 9 marks. So without wasting much of the time, let's jump right in. All right. So question 10A reads, answer this part of the question on a sheet of graph paper. So we're going to answer the whole of this question 10A, the whole of question 10A on a sheet of graph paper, and question 10B on the answer booklet. All right. So the values of x and y are connected by the equation y is equals to negative x cubed minus x squared plus 6x. Some corresponding values of x and y are given in the table below. So these are some of the corresponding values. We have negative 3, 18 up to 4, q. Okay, so we're interested in here where there is a variable, a missing value. Okay. Now, the first question here, we're asked to calculate the value of q. Calculate the value of q here. And when you look at q, clearly here is on the y-axis. So, this is how you solve it. Okay, so this is the graph paper here. This is the Zambian Standard graph paper. So, what we're going to do, we write the question number. So, this is question 10. So, we're going to write here question 10A. Okay, question 10A. So on this graph paper, we're going to copy the original equation, which is this equation here, A1, 1 here, if I'm not mistaken, the equation number, yes, Roman numeral 1. So when you copy that function, the function is y is equals to negative x cubed plus x squared plus 6x. Then here, the missing value here is on the y-axis. So we're going to substitute y with q. Okay, like this. So we're going to say q is equals to, then we're going to substitute x with what? With 4. When q is, when y is q, x is 4. So wherever there is x, we're going to substitute with what? With 4. So since here there is already a negative here, so we're going to substitute x as 4, so it will be negative, then 4 to the power 3, like this. Alright, so everywhere there is x, we're going to substitute with what? 4, so then here will be just 4 squared plus 6 times 4, like this. Therefore, the value of q is equals to, when you punch everything here on the calculator, we're going to find, okay, so here, negative 4 to the power 3, we're going to have negative 64. 4 to the power 2 is just 16. 6 times 4 is 24. Okay, so when you add everything here, we're going to find the q as negative 24. Okay, so we found the value of q. Let's now go to the next question. So the next question here is saying, which is question 2, is saying, using a scale of 2 centimeters to represent 1 unit. So using a scale of 2 centimeters to represent 1 unit on the x-axis. And then this is the range. The range should range from 0, -3 to +4. Okay, and so it represents 10 units on the y-axis. This is nice. Then -30 to 20. So this is what it means. Okay, this is what it means. When they say 2 centimeters to represent 1 unit on the x-axis, then negative 3 to positive 4, 2 to represent 1 unit. This is what you do. Okay. This is what it means. You know that this one also has negative numbers. So you can't start from here. Okay, you can't start from here like we've done for, we do for statistics and linear programming. So here, you think critically where the middle line will be, okay, or the initial point. So what you do is, since you are taught that to use 2 centimeters to represent 1 unit, 2 to represent 1 unit, and each box here is 1 unit. So let's take, for instance, if we start from this line, okay, if we start from this line, are the boxes going to fit? Are the numbers going to fit here in the boxes? So if this one is going to be our y-axis, okay, our y-axis, then this one will be 0, 1, 2, 3. So this will be negative 3. These are negative numbers. From here to be 1, 2, 3, 4. So in the x-axis, when this one is 0, it works. How about y-axis? Okay, so we're going to use this line. Okay, this one as y-axis. Now, how about now the y? We're going to use x is equals to 0. This line. Okay, this is the line we're going to use. How about the y-axis? Y-axis, we are told to use 2 centimeters to represent 10 units. 2 to represent 10 units, 2 to represent 10. From negative 30 to positive 20. Okay. Remember, our x value is 0 here. This is the y-x is 0. So we're going to use this line. Okay. Now, we are going to start from y. Now, if we begin from here, let's check if this will be 0. This will be 2. These are 2 centimeters box. And we are told to use 2 centimeters to represent 10 units. So this will be negative 10, negative 20, negative 30. It makes sense. Okay. Going up to what? To 20. This one makes sense indeed. 10, 20. Okay. So this one is going to be, if this is 0, negative 1, negative 2, negative 3. 1, 2, 3, 4. Yes, it's making sense. So I'm using a pen on the graph paper because I want it to be visible. If I use a pencil, it may not be visible. Okay. So this will be our 0. This will be our negative 1. This is our negative what? Negative 2. This is our negative 3. Okay. This is our positive 1. This is our 2. This is our 3. And this is our 4. Going down, we are told to use 2 centimeters to represent 10 units. So this is our negative 10. Okay. Negative 20. And negative 30 here. Negative 30. Going up 10, 20. I think this is what is here. Let's check. 2 to represent 10 units on the y-axis, negative 30 to 20, positive 20, negative 30 here to positive 20 here, okay, like this. Then, what else do we have? 2 to represent 1 unit, all right, 2 to represent 1 unit from negative 3 to positive 4. Check here. This is 2 to represent 1 unit, okay, in the x-axis. Then from negative 3 to positive 4, okay, like this. Now we can start plotting, okay. So we're going to use our table here to plot. Okay, let me do this. Okay, so there you go. The first coordinate is negative 3, comma 18. Negative 3 is here, comma 18, positive 18 is up somewhere here. So we need to make sure you know the value of each small box. Now there are 10 boxes here, so you count the unit given divided the number of boxes. So here you have 2 to represent 1 unit. So you have 1 divided by the total number of boxes. Even if you use negative sign here, the sides. By the way, you just use the unit given, which is 1 here divided by the total number of boxes, which is 10. It will give you the value of each small box, okay, in the x-axis. So 1 over 10 is 0.1. So let's check if at all this one works. 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Yes, it works. How about here? 2 represents 10. So it will be 10 divided by 10. These 10 units divided by 10 boxes, it is 1. So the value of each box in the y-axis is 1. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 10. So this makes sense. Or even if they're giving us negative 3 to 18, we will know where 18 is. So negative 3 is here, comma 18. So this is 10. 11, 12, 13, 14, 15, 16, 17, 18. 18 here. Okay? 18 because this is 19 and this is 20. Alright? Okay, like that. So, what we're going to do is to go to the next coordinate. So this is our first coordinate. The next coordinate is negative 2 here, comma 0. Oh, just here. Just here. So this is where 0 is, 1, 2, 3, up to 10. So it's not to negative 2, comma 0. It is negative 2 here. When you go to the x coordinate, don't lift the pen. You can either go up or down. So don't say negative 2, comma 0 here. It is negative 2. Then try to check where is y 0. Here y is 10. Here y is negative 10. Here y is what? 0. So it is 2, comma 0 is here. Next point is negative 1, comma negative 4. Negative 1 is here. Negative 4 is also negative 1. Or negative 1 here. 1, 2, 3, 4. So negative 1, comma negative 4 is just here. Okay. Next is 0, comma 0. 0, comma 0 is here. Right here. Alright. Next is 1, comma 6. 1 is here, comma 6. So 1, 2, 3, 4, 5, 6. 6 is right here. See, our shape, our cubic shape, function shape is forming. Okay. Next is 2, comma 8. 2 is here. 1, 2, 3, 4, 5, 6, 7, 8 here. All right. Next is 3, comma 0. 3, comma 0 is just right here where 3 is. Okay. See, the shape is forming. Next is what? The next is 4, comma q. What is the value of q? We've already calculated the value of q. Somewhere here, q is negative 24. Okay, so we can plot this one as negative 4, comma negative 24. So this is 20, negative 20. All right, negative 20. So it will be negative 20. This is negative 24, negative 21, negative 22, negative 23, negative 24, right here. Okay, you see the shape that is forming? It's like this, an S shape. Okay, so let's draw a smooth curve connecting those points. Okay. Okay, so let's join the points. Now, remember, like I told you, use a pencil, okay, to avoid mistakes, because on the graph, a pen you can't erase on the graph and you just waste time, okay, starting again. So, but me, I'll use a pen here just for illustration purpose, and also for it to be visible, okay. So make sure So we're going to start, we can start with anywhere, either from this point or this point, as long as it will be what? Neat. Okay, so our graph is moving like this, point, that point there, okay, to that point, okay, from there, okay, something like this. This is passing at 0 here, this point, can you see the shape is forming? Okay, so we're only remaining with one point here, so we can draw it like this up to here, you see. So that is our shape. So you can just write clearly, nicely here. This shape is y is equals to negative x cubed plus x squared plus 6x. Something like this. Alright, so this is nice. We can go to the next question. So this is question 2. You can write the question number here. Question 2. Next question here is saying, use your graph to solve. Wow, this is nice. This is very, very good. Okay, use your graph to solve. This is question 3A. Okay, I'll solve it from here where there is space. As long as you indicate the question numbers 1, 2, 3. Question 3A. I'm saying use your graph to solve this equation. So this is what you do, guys. Write the original equation, like this original equation first, like this. Okay. Then write this equation, which is to solve the equation. Just write it down here. So it is negative x cubed plus x squared plus 5x is equals to 4 minus x. Okay, 4 minus x. Look at this nicely. 4 minus x. Check. We are taught to use the graph to solve this. Now, is this function here equal to this function? No. Okay, it is not the same. What is the difference? Here there is a 6x, here there is a 5x. So make it the same. So now there are two ways of making this the same. Since this is 6x and this is 5x, so what you can do, you can add the x to both this side here and this side, so that it becomes 5x, 6x. Or since you have already an x here, this x can come to this side. This is negative x. When this negative x crosses the cosine, it becomes positive x, and to be 5x plus x, which is 6x, then these two equations will be now equal. Okay, will be equal. All right. Now, let me show you what I mean by solving. How can you make this equal? It's not by adding 1, because 1 is not this. They're not like terms as this. So what you do, you add x. Add x both sides here and also this side. This is the common method that you use. So when you add here, it will be 6x. Therefore, you can cancel this. Okay. Now this side, negative x plus x is just 0. So y is equals to what is the remaining value there is 4. So you go where y is equals to 4 on the graph. Where y is equals to 4 on the graph. So we are going to use a ruler to draw a line where y is equals to 4. Okay, where y is equals to 4. Now first you count, this is 0. Remember, each graduation here, each small box is 1 in the y-axis. So this is 1, 2, 3, 4. 4 here. So you draw a straight line. Okay. So you can say, okay. So you draw a straight line cutting the curve. You make sure you extend, you don't just end here. You extend the line until you know that this line is cannot cross the curve or cut the curve anymore. So this is y is equals to 4. Now this is not the answer. We don't end here. Check. This straight line is cutting the curve. Oh, by the way, remember to draw the x or y plane. This is very, very important to draw the x or y plane. All right. So this is the y-axis. Remember, this is the y-axis. Y-axis. Okay. This is the y-axis. Then this is the x-axis here. This is the first thing you begin with after interpreting the scale. Okay. After interpreting the scale. Something like this. This is good. Looks neat. So this is x axis, and then this is what? This is our y axis. Okay, something like this. Then what you do, remember what I told you? We get back to this question. Where this line is cutting the x-axis, that's where the solution is cutting the curve. That's where the solution is. So check. This line is cutting the x-axis here. And I mean, not cutting the x-axis, cutting the curve here and also here. If you can see this line here. So those are the answers. So you have 1 here. What is the value? The value of each box, remember, is 0.1 in the x-axis. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So one of the solutions is 0.7. So you can write here, when y is 4, x is 0.7, comma, check. What about here? This is 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. So another answer is 2.6. X is equals to 2.6. Next is this one here. So you can start with any, as long as you can start with any value here. So there is 2 here, negative 2, negative 2.1, negative 2.2. So you can write here x is equals to negative 2.2. Okay, negative 2.2. These are the answers. Okay, these are the solutions to this question here. Okay, to this question, this first question here. All right, that's why it's even 3 marks, because yeah, it's a little bit involving. Okay, remember what I told you. First, some of you may not understand. Write the original equation. Write the equation that is given there. Compare the two. If they are the same, everything is just the same. Cancel. Then equate y to whatever is this side. If y was equals to 0 this side, our answer or solutions would have been in here, in the x-axis. Would have been here, negative 2, x is equals to negative 2, x is equal to 0, and x is equals to 3. Now it's y is equals to 4. Y is equals to 4 here, and the line y is equals to 4 is cutting the curve here, this point, and this point here. Okay, so that's how simple this is. Let's go to the next question, which is the last question under cubic function before we answer the calculus question. Check. Okay, so look at this. The question, we are taught to use the graph again to estimate the gradient of the curve at the point where x is equals to 1, positive 1. Just estimating the gradient where x is equals to 1. Check. This is where x is equals to 1. The curve is this point. All right. So we're going to draw a tangent line. Okay, like this, where x is equals to what? Where x is equals to 1. So touching just this single point. Okay, single point, we're going to draw a line touching that single point. X is equals to where x is 1 on the curve where x is 1, like that. So this is the line, and x is what? X is 1. X is 1, not the straight line. So guys, this is the line. Now we need to calculate. This is very simple. Estimating the gradient is very simple. Just get 2 points, any 2 points in this line, and use them to calculate what? Use them to calculate gradient. So the first thing, just get the first coordinate. This one, the same point, which is what? 1, comma, what is the value of y? 0 here, 1, 2. 1, 2. Okay, 1, 2, and get any other point. So where can I get here? Can get this one. I can get this. Any point you can get. Okay, let me get this one. This is 0, 1. Is it 0, 1? Sorry. This is not 1, 2. I thought this is the x-axis. So it's from here. Okay. It is not 1, 2. This point here is not 1, 2. It is 1 here, 1, 2, 3, 4 here. This here is 4, 5, 6, 1, 6. Yeah, these are some of the mistakes that are made. Okay, so make sure that you know the x and the y axis. Okay, so 1, 6. Then you can get this point as well here. Okay, you see. Let me do this. Okay, I mean the second box here. Okay, the second box. This is the first box. The second box is here. So this is 0, 1. Okay, this coordinate is 0, what? 1. Okay, now we have the two what? Now we have the 2 points. We can use them to calculate the gradient. We have 0, 1 and 1, 6. Okay, so the formula for gradient is, the symbol is m is equals to y2 minus y1 over x2 minus x1. Okay, like this. Then let's substitute. Let's call this one x1, this one y1, this is x2, y2. Okay, or the other way around, this will be the 1s, then 2s, no problem. So gradient is equals to y2 is 6, okay, minus y1 is 1 over x2 is 1, x1 is 0. So this one is giving us 6 minus 1 is 5, 1 minus 0 is 1. So this one is giving the estimate gradient as 5. Here it's giving us 5. So whatever point you're going to get here, you should find a similar answer. Okay, a closer answer, since you're just estimating. If you get this point, it's going to be 2, 11. 2, 11, and this point will be 11 minus 6, which is 11 minus 6 is 5, and 2 minus 1 is 1. 1 into 5, still 5, you see? Still 5. So get any 2 points. We're going to find the correct answer. So that's all to this question 10A. Hi guys, good morning, good afternoon, good evening, whenever and wherever you're watching this video from. Welcome to Nostec Academy. In this video, we are going to answer question 11 of 2024 Mathematics GCE Paper 2. Alright, so if you are new to this channel, please consider subscribing and also liking the video. Okay, so without wasting much of the time, we are going to answer question 11A and 11B. Okay, this question is divided into two. By the way, this is statistics. All right, and the statistics is divided into two. According to this, there is standard deviation, and there is this part which you are supposed to solve on a sheet of graph paper. Okay, so let's start with the standard deviation here. Okay, so we're going to solve this part on this plain paper. Okay, so we're going to say, so there are two methods you can use to solve standard deviation. There is a table method and the formula method. So in this video, we're going to use the formula method. Okay, now when you look at the type of data here, this is grouped data. Okay, it is grouped data. There is a range from 10 to 20, 20 to 30, up to 70 to 80. So this is what? This is grouped data. All right, we are given the total frequency or total learners here as 50. The frequency table shows the distribution of marks obtained by 50 learners in a mathematics test. Okay, so when you add frequency here, we should have 50. It should be equal to what? It should be equal to 50. When you add 3 plus 7 plus 12, 15, 8, 3, and 2, should be equal to 50. Now, since I said we are going to use the formula method, let's begin. So this is 11A. So we're going to say standard deviation is equals to, okay, the square root. This is the formula, the square root of the summation of fx squared over summation of f, which is frequency, minus x, the mean, x bar, close bracket, squared. Close bracket, squared. Okay, this is the square root. All right. So to find, so we're going to first find the mean. Let's find the mean, which is x bar here. So the formula for finding the mean is summation of fx over summation of what? Of f. Now, when you analyze data here, f is frequency, okay? X is the midpoint. Then summation of f, this is total frequency now, which is 50. Okay, now let's begin. Using this formula, we're going to say x bar is equals to, what is the mean? The frequency here, which is f. The frequency is 3 multiplied by, we're going to multiply 3 by the midpoint. So I usually tell students to write like this, so that you don't make mistakes. First, write all the frequencies. Okay, just 3, you can write 3 multiplied by open bracket plus 7 multiplied by open bracket close plus 12 multiplied by the midpoint, of which we will substitute later on, plus 15 multiplied by open close bracket plus 8 open close plus 3 open bracket close plus 2 open bracket, then close bracket, divided by total frequency, which is 50. Okay, 50. Now let's substitute the midpoint. This is grouped data. So what is the midpoint between 10 and 20? You add 10 plus 20, which is 30. 30 divided by 2, it is 15. So just add 5 to the first number. This 10 plus 5, 15. 20 plus 5 will be 25. 35, 45 will be our midpoints. Okay. So we're going to say between 10 and 20, it is 15. Then we're going to add 5 to 20, it will be 25. 25. 30 plus 5, 35. Then you have 45, 55, 65, 75. Okay, 75. So you can punch everything here on top on the calculator. You can say x bar is equals to. So when you punch everything in the calculator, it will be like this. Okay. So everything then is equals to 2100 is giving me 2100. Can you just confirm on your calculator as well? So 2100 divided by 50. Okay, so the same answer divided by 50, we're going to have 42. Wow. So the mean is equals to 42. Now take note, this is the mean. Okay, let me just write it here. This is the mean. Okay, now when you look at the formula here, on the formula, there is the square here. There is this one which is squared. So meaning, we can also write mean squared, of which we're going to square this 42. 42 squared. All right. So 42 squared, it's giving me, so which is x bar squared, it's giving me 1764. 42 squared, 1764. So this is this part here. So let's now calculate this part. Now you notice that this part is very simple. This part is very, very simple. Why am I saying this? Because, let me just write it here, this side. It is summation of fx over summation of frequency. Okay, do like this. Frequency is equals to, copy the way it is, everything here. Okay, so we're going to copy this part here. Okay, like this. Okay, so I've copied the way it is, everything here. If you look at the first one, is 315, 725, 1235, 1545, 855, 365, 275 divided by 50. But we need, this one is supposed to be squared. By the way, f of x is squared. So we need, the x should be squared, the midpoint. So this is the midpoint here. So to the numbers that are in brackets, we're going to square them. That is the only difference here, like this, like this, like this, okay, like this. Okay, we're going to square them. Then let's put everything in the calculator. Okay, so this on the calculator, it will look like this. Okay, what is the first number here? 3. You can see this is 315 to the power 2 plus 7, 25 to the power 2 plus 12, 35 to the power 35 to the power 2. Okay, like this. So everything here, then I'm going to punch the equal sign. So this is giving me 98,250. Okay, it's giving me 98,200 what? 50 divided by 50. So when you divide by 50, we are going to have 1,965. 1,965. What is this figure? This figure, it is the summation of fx squared over summation of frequency. Okay, total frequency. Now, having found the mean x squared and also the summation this party, we can calculate the standard deviation. We can write SD is equals to the square root of the summation of fx squared minus x mean squared over summation of f the square root. Now let's substitute what we have. When you substitute here, this part inside, so we're going to say square root, this part inside is 1,965 minus this mean here, the mean inside, it is what? 42. Then the mean squared is 1,764. Okay. So when you subtract inside there, 1,965 minus 1,764, we're going to have 210. Okay, 200 what? 210. All right. Then let's find the square root of what? Of 200 what? 210. The square root of 210 is 14.177446877878758. Now, when you round this one off to two significant figures, we're going to have 14. To three significant figures, we're going to have 14.2 because this 7 is greater than 5. So we're going to add 1 to the one, this one, and it becomes what? 2. So it is 14.2 as the standard what? As our standard deviation. So that's the answer to the first question here. Okay, question 1. Let's now go to question what? Question 2. Okay, so the second part of this question is saying, answer this part of the question on a sheet of graph paper. The first question is saying, using the information in the table above, copy and complete the cumulative frequency table below. So this is the cumulative frequency table. So we need to copy it and completing it. So on the graph like this, okay, like this. Now on the first part here is there is 0, so let's put the numbers that are already here. There is 0 here, 3, 10, 22. So what do we do? So this is how we add. Okay, look at the distribution of marks in the frequency table here, not cumulative but just the frequency table. So the distribution of marks are like this. 3, 7. So what you add 0 plus the first number here. 0 plus 3 is giving us 3. 3 plus 7 is giving us 10. 10 plus 12 is giving us 15. 10 plus 12 is giving us 22. 22 plus 15 is giving us 37. So here we're going to write 37. Okay? Then there's the same 37. 37 plus what? Plus 8. 7 plus 8 is 45. Then 45 plus the last one is what? And you have 3 boxes. Let me check. Okay, so we have 45 is where 60 is. So we're going to add 45 plus 3 is 48. Okay, 48. 48 plus 2 here is 50. The last number here should be equal to the total frequency, which is 50. So this one is correct. Okay. Now let's answer the second part, which is part 2 on our graph. Here we can write question 2. All right, question 2. They're saying, using a scale of 2 centimeters to represent 10 marks on the x-axis from 0 to 80, then 2 centimeters represent 5 units on the y-axis. Okay, so these are the units. Now, what I usually tell you, this is, by the way, the Zambia Standard Graph paper. Start from the second last corner here. Okay, start from here. Now, when you start from here, in the x-axis, we are told that 2 centimeters to represent 10 units. Then the range should be 0 to 80. So we're going to say you need to have 10 to represent 2 to represent 10. So you need to have 8 boxes. So if here is 0, then here is 10, 20, 30, 40, 50, 60, 70, 80. Because it is 2 centimeters to represent 10 marks. Okay, so here we can write 10, 20, 30, 40, 50, 60, 70, finally 80 there. Okay, and then in the x-axis, that's where you have the marks. Okay, that's where you have the marks in the x-axis. So we can write here marks. Okay, marks represented by x there. Then in the y-axis here, we are told that it is 2 centimeters to represent 5 units, and it should end on what? 50. 2 to represent 5 units. So we are going to say 2 to represent 5. This is 2 centimeters. So here it is 5. 5 plus 5, 10. 10 plus 5, 15. 20. 25. 30. 35. 40, 45, 50 here. Okay, 50. Then here we're going to write cumulative frequency. All right, like this. Okay, cumulative frequency. Cumulative frequency. Then, okay, like this. So now let's start plotting using the coordinates here. Okay, so the coordinates that are on top, number that are on top here, these represent the x-axis. Then here on the cumulative frequency represent the y-axis. So the first one, of course, it is 10, 0. Okay, 10, 0. So 10 is here. 10 is here, and 0 is just the where 10 is, the same place here. Y is 0 here. Oh, by the way, let's draw the x or y plane first. Okay, so this is the x or y plane. This is how it looks when you draw the x or y axis. Now let's start plotting, or we continue plotting. The first one was 10,0, next is 20,3. Okay, 20,3. So 20 is here. Then what is 3? Listen, if let me explain using this paper. So listen, if it is 10 to represent 5 units, then you divide the unit which is 5 over the 10. Okay? I mean the 10 boxes here. Okay, 10 boxes. So you divide the unit which is 5 divided by 10 boxes, and we're going to divide 1, 2. So 1 unit is equal to 2 boxes. Okay, 2 boxes. So here we're going to say 2 boxes here is 1. So 1, 2, 3. So 3 is here. Let's prove if at all is going to be 5. 4, 5. So when say 20,3, it is here. Okay, this is where 20,3 is. Next coordinate is 30. It's 30,10. Okay, 30,10. We go on our graph. 30 is here and 10 is here, so it will be just like this. Simple as this. Alright, the first coordinate is here 10, then you have 3 at 10 here. Okay, next is next coordinate is 40,22. 40 here, 22. So 40,22, we're going to say 40,20 is here. 22, so it will be 4 boxes. 21, 22. So 22 is here. Okay, that's why 22 is. Next coordinate is 50,37. Okay, so where 50 is here, then 37, 30 is here. Okay, 35 here, 35 is here. So 36 is here, 37. Okay, 37. Remember, 2 boxes represent 1 unit. Okay, like what we've discovered. Next coordinate is 60,45. 60,45. Let's go on the x-axis where 60 is. 60 is this is where 60 is. 60,45. So 45, 60,45. 40 here, 45 is here. Okay, 45. Next is 70,48. So 70,48. On our graph, 70 is here. This is where 70 is. So go straight up to 48. So 45 is here. So 46, 47, 48. Let's prove if at all it's going to be 50 when we continue. 49, 50. So this is 48. The last coordinate is 80,50. 80 here. Then we go straight to where 50 is. So 80,50 is here. So these are the points. From here, going like this, here, this point here, this point up to 10 here. So let's draw a smooth curve. Let's draw a smooth smooth curve. Remember to use a pencil. Everything I'm doing on the graph paper should be done using a pencil. I'm using a pen because a pencil may not be visible to you. Okay? So, but I will start with a pencil, then okay, so let's just proceed anyway. From this point, using a free hand, not a ruler. Okay, like this. All right. Okay, like that. Then is this a point? Is that 20,40? Yeah, 40,20, 40,20. No, it's 22. So it's just here. Okay. This is a problem. Okay, let's proceed from this point to this point here. So we're remaining with 2 more points here. Okay. Okay, this is where problem is. So make sure it's a smooth curve. Shouldn't have double lines. Okay, like this. Okay, this is the smooth what? Smooth curve. Okay, next question. So we're done with question 2. Let's go to the next question. Next question is showing your method clearly, use your graph to estimate the 70th percentile. Wow, 70th what? Percentile. So we're going to go on our graph here. On our graph, and I'm going to do a little bit of calculations here. Let me just do a little bit of calculations. This is question 3. They're saying 70th percentile. Okay, 70th percentile is just the 70%. So what you do, you calculate 70%, which is percentage is out of 100, so it will be 70 over 100 multiplied by the total frequency, which is 50. Or you can go here, total cumulative frequency. Total cumulative frequency is here 1 or 5. 50, I mean, sorry. It is 50. All right, so we're going to write here 50. Okay, so solving this 50 here 1, 50 here 2. 2 into 70, it is 35. This is not the answer. No, it's just telling us that we should go where the cumulative frequency is 35. 35 here. That's where 35 is. Then we're going to draw a straight line where 35 is here. Okay, like this. A straight line up to where it is touching, up to when it touches what? The curve. Alright? Immediately when it touches the curve, you drop it down to the x-axis. Okay? We want to know the 70% of our data. Okay? The 70% of our data. So when you go down, this is how it looks like this. So you can indicate here as the 70th percentile. 70th percentile. Now you check. You ask yourself, what is the value of x here? Okay, so in the x-axis, it is 10 boxes, or 2 centimeters to represent 10 units. Then how many boxes do we have? 10. Then the unit is 10. So it means that each box here is 1. So 20, 30, 40. This is 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So this is 48. Okay, 48. So you can come to your graph here. You write 48 marks. Okay, 48 marks. The 70th percentile is 48 what? 48 marks. Okay, because here it is giving us what? 48. Okay, so that's it to this video on statistics, which came in 2024 GCE. Thank you so much. Remember to subscribe. This is the only way you can help the channel grow. Okay, so let's solve question 12 12A and B. Just question 12, the whole of it. Now question 12, it is a combination of two topics, earth geometry and mensuration. Very good. Mensuration. So let's start with the first one. The first one, they're saying, they're just given points, and then we are asked to do what? So I'll give it the points P, Q, R, and T. I mean 4 points, right? Are on the surface of the earth. Take pi to be 3.142, and the radius of the earth should be 6370 kilometers, right? Yes, kilometers. Draw. So question 12. This is 2024 GCE, of course, paper 2. Draw the scale. So the first thing, just draw a circle.
Yes.
So question A1, just draw a circle. Okay, like this, something like this. Then a circle. This is north, right?
Yes.
This is south. This is west, and then this is what? East. Now north, west, east lines that go west east are latitudes, right?
Yes.
Then north south are longitude. So let's start with the first point. The first one is only 80 degrees north. So above, right? So we're going to draw something like this, Okay. I would have used a pencil, but anyway, let me just use a pencil that it is what? Visible.
Yes.
Okay. So this is the other side, right? This is 80 degrees north. Okay. 80 degrees north. Then they're saying 50 degrees where? West. Okay. This side. How many degrees? So you can just label this one as 50 degrees west. So where is point P?
It's there, where they...
Here?
Yes.
So this is where P is. You are done with this, that point, right?
Yes.
You go to the next, which is Q. It's only 80 degrees north, meaning it's this one, but 80 degrees east. So we can just extend this one and do like this, Okay. Then label this one as 80 degrees what? East. Now where is Q?
Where?
Here. So that's where Q is. Next. R, right?
Yes.
R is 50 degrees. Where is R? 50 degrees north, So it's also above.
Yes.
Okay. So is it supposed to be above 80 or below? Below, right? Because the equator, there's an equator here which is 0, so it's supposed to be down here, like this,
Yes.
Then we can also draw the other side so that it looks, let's see, 3 dimensions. This is 50 degrees north. Then, comma, 80 degrees east. Here,
Yes.
So this is R.
Yes.
And the T is only 50 degrees north. So we don't have south, this was nice. We don't have south. So on this one, it's supposed to be here. Am I right?
Yes.
50 degrees north, but 50 degrees where?
West.
So this is T. Okay? Now, this is the sketching. We are done sketching. Yes, sketching. Now, let's solve question 2. Question 2, they're saying, let me solve from here. Where is visible? Question 2, they're saying, calculate the distance QR. This distance is along the longitude. So you know the formula to use, So it's going to be QR equals to theta, which is the angle, the difference in latitude,
360 or 180, then here don't use a 2, but let's just use 360 pi r. Just like that, eh? Pi r. Now, the theta is the difference in latitude. This is Q is on latitude 80. This one is on latitude what? 50. Both are on the same latitude, same hemisphere, not north. I mean, same hemisphere. So what do? Do you add or subtract? You subtract, right? So it will be 80 minus, which is what? 30 what? Degrees, right? So it's going to be QR is equals to 30 degrees over 360 times 2 times 3.142 times 30, 6370 is in kilometers, 6370. Someone to calculate QR. Okay, 30 divided by 360. So after calculating is giving us 3,335.75. How many sixes? Then 7, Is the degree of accuracy specified here? No. What does the instruction state if the degree of accuracy is not specified? We leave our answer correct to how many significant figures? 3. So 1, 2, 3. Okay? Then the number above 3 will add 1 to this one, And then the number itself becomes 0. Becomes 0. Then this one becomes 4. Then this one remains 3 kilo. Very good. So 3,340 kilometers. We have another last one. RT. Here, RT. This is the distance along the line of latitude. Yes. Okay. So RT is a line of latitude. Then what's the formula? The formula, the formula is going to be RT is equals to theta over 360 times 2 times R cos what? Cos X, right? Cos X. So remember what I told you so that it becomes easy. If you forget, you can remove this 2 and divide it to this one and just write 1/8. But if you are not confident in that, then let's just do it the way we've been doing it. So therefore, our theta will be the difference in longitude. Okay, so this one is on 50 degrees where? And the other one is on E. So we add. The difference, so it's going to be 130 degrees. So here it's going to be 130 divided by 360. 130 divided by 360 times 2 times 3.142 times 6370 cos. Now the X is the latitude on which TR is. On where? 50 degrees, Yes. 50 degrees. Okay, like that. What's the answer? So after calculating here, passing everything on the calculator, we have 9,291.459902. We also round it off to 3 significant figures, am I right? Because we are not told the degree of accuracy. So this is 9, and the number after 9 is less than 5. So the 1 becomes 0. Then 9 remains as what? 9. Then this one? 2. Then 9. Kilowatt? Kilometers. So that this This is the solution to this question. Okay, we go to question BI, which is mensuration. Okay, so mensuration of 2024 paper 2 GCE came with earth geometry in section B. So this is the question. All right. So what we're going to do here. This is the first term of a cone. I think yes, it is. So we are given the base of the larger cone here. The base of this first term as 2. The radius, I mean, as 2 centimeters. Then here we don't know, right?
Yes.
Okay. Then we are given the height of this first term. Okay. First term here. Then we are told to do what? To find the value of r if the height of the cone from which the first term was made was 60 centimeters. What is the meaning of this statement? If the height of a cone from which the first term was made was what? 6 centimeters. Is this the height of a smaller cone or the height of a larger cone?
Larger cone.
Larger cone, right?
Yes.
Yes. Okay. Before this one was cut off, okay, was made, the height was 6. Okay. So this is what we're going to do. We still use proportions, right? So we're going to say radius of the larger cone, okay, over radius of the smaller cone, which is just what? R. Height of the large, we are dealing with cones here. This is not a cone. This is the first term of a cone. It's like a bean. Right?
Yes.
So height of a larger cone over height of a smaller cone. Let's use just small letter h. Yes. Then let's substitute the values. Then we're going to solve the value of small letter r. What is the larger radius? All right. So radius of the larger cone is 2, right? Okay, so we're going to substitute here with what? 2. How about radius of the smaller cone? We don't what? We don't know. We're going to write just r, right? It's the one we want to find. Is equals to what is height of a larger cone? 6. Okay? Over what is height of a smaller cone? No, this is not a cone. This is not a cone, not 3.6. The height here, if you extend this one, so it will be 6 minus this. We have to find the height of the smaller cone. Come on. 6 minus 3.6. What is the answer? 2.4. Then cross multiply. So here is going to be 6r, am I right? Then here is going to be what? 2 times 2.4, quickly. 4.8, yeah? 4.8. Then we divide by 6, right? Both what? Sides, by 6. Yeah, even here would have just even here would have just substituted 6 minus 3.5, 3.6. No problem. Answer will still be correct for this one, right? Okay. So r is equals to. So listen before you find the answer. If the radius of a larger cone is 2, what do you expect is the radius of a smaller cone? To be greater than 2?
No.
Less than 2, right? What is 4.6 divided by 6? 0.8. 0.8 what? Centimeters. Okay? This is question B1, right? Number 2, find the volume of first term, which is now 4 marks. Volume of this. There's no problem. There's no
problem.
So we're going to say number 2, volume. So we're going to use the normal formula. Okay? The normal formula, which is 1/3 pi r squared what? H. I'm using capital letters here for a larger what? Cone. Minus 1/3 pi r squared h. These are small lower cases for volume of a smaller what? Cone. Okay? Volume of a smaller cone. Okay, so let's substitute. So volume is going to be 1 over 3 times 3.142. Am I right?
Yes.
What is radius of a larger cone? 2. So it will be 2 what? Squared. Height of a larger cone? 6. Okay, minus. Okay, 1 over 3 times 3.142. So don't mistaken 3.6 as the height of a smaller cone. Oh, I mean radius. Is this radius? What is the radius? We found 0.8. Yeah, I wanted to explain his height. Don't substitute 3.6. This is height of a larger cone. If you don't understand this, let me make this like this. Okay, let's say this is a cone. Okay, a cone. Then they're saying from here up to here is 6. 6 centimeters. Then they're saying then from here up to here is, let's say, 4. Then what is the height of this cone here? We subtract 6 minus 4 so that we have 2 here. So we can't get this one. This is not a cone. This is just a frustum of a cone. Let's now solve. So when you pass on the calculator, what is the volume of a larger cone? So the volume of a larger cone is 25.136.
Yes.
Minus, what is the volume of a smaller cone? Okay, so here, this is radius, or height. Height is supposed to be 2.4. Okay.
7.
Yeah. So don't forget that the radius should be what? Should be squared,
Yes.
Okay, and our what? Our height is 2.4. What's the answer?
1.60.
1 point. Okay, so the volume of the smaller cone is 1.608704. Okay, when you subtract, what are you having? When you subtract, so when you subtract, we're going to have 23.52 7296. 96. When you round this one off to 3 significant figures, you have 1, 2, 3. Am I right?
Yes.
So you have 23.5. Since this one is less than 5, okay, 23.5 what? What are the units? It's centimeters, so it's cubic what? Centimeters. Okay, so that's all to this question.